that recording shortly. And that's a good thing, because we were just discussing before people started to arrive how good it is to have those recordings even a year or two down the track to be able to refer to. So that recording will be available on the IWN Knowledge Hub in a few days' time. Just a couple of formalities. You're probably all used to it by now after a couple of years in working in this manner, but please remain on mute unless you have a question. But today for questions, we are not going to use the chat. We are using a Menti board, and Elisa's put into the chat the link to the Menti board. You just simply go to menti.com. You can do that on your smartphone, or you can do it on another screen using your browser. And the code is 82729075, as is in the chat. You just put that in, and then it will bring up a little dialog box for you to put your questions in, and those questions will come through during the presentation. We will then throw to Q&A at the end of the presentation, and we'll go through those questions. One of the great things about Menti is that if you've got, you can actually upvote a question. So if you've got the same question, you don't have to put it in again. You just simply vote for that question, and the question with the most votes gets to the top of the pile. So feel free to upvote the questions as you see them arrive. Now, it gives me great pleasure to introduce and to hand over to our host for the day, Kevin Hellier. Kevin is the team leader of technology and solutions at Melbourne Water. Most importantly, is the program manager of our IWN data and analytics program. Kevin, it's over to you. Thanks.
Yeah, great. Thanks, Jason. And hi, everyone. Hey, I'm Kevin Hellier from Melbourne Water, and it's with the help of Jonathan Crook from Southeast Water that I manage the IWN's data and analytics program. And yeah, so I've got the privilege today of introducing the webinar topic and our great presenter, Gareth. I'll start with a little bit of background. Last year, IWN began a really great relationship with a new Australian company, FSA Data. And we partnered in a couple of trials with FSA Data's newly developed software called SensorClean. And these trials were completed last year, and as IWN members, we all have access to the reports of these trials on the IWN Knowledge Hub. I was really immediately attracted to the idea of SensorClean because it aligned with one of our program's priority focus areas, and that had been worked up by our working group previously, and that area was managing data quality. And you know, as water utilities, we all hold large amounts of time series operational data, typically acquired through our SCADA systems and nowadays more increasingly via IoT platforms. And you know, our capabilities are growing in the use of this data for planning and operational optimization, because we've got more accessible analysis and modeling tools. And some of the questions that we have in this program is, how important is the accuracy of this data to get the outputs we need? And how do we shift the time and effort of our people from data handling tasks to focusing on value-added analysis and decision-making? So these are some of the challenging ideas that today's webinar helps us consider. And so it's my pleasure to introduce Gareth Williams now. Gareth is the CEO and co-founder of FSA Data, and he's committed to building software that provides useful visualization of monitoring data to inform decision making. Gareth's PhD research focused on analysing Hunter Water Corporation's monitoring data at the time of historical pipe failures to understand system operations associated with failure. He has professional engineering experience in both the public and private sectors while working in Australia and Canada, as well as published work by the American Society of Civil Engineers in the Journal of Water Resources Planning and Management. So now, Gareth, it's over to you. Welcome.
You're on mute, Gareth.
Sorry, guys. Yeah, thanks very much for the introduction there, Kev and Jason, for the warm welcome. I really appreciate it. And thank you all for coming along today. Really appreciate the opportunity to present the IWN. Yeah, as Kev mentioned, we've had a couple of great trials with the IWN. In 2020, it was potable water, kind of SensorClean development, and the conversations with the participant utilities, Goulburn Valley Water and Western Port Water, really informed the development. And then more recently in 2021, we kind of moved towards a sewer conceptual version, which has kind of automated reporting for dry weather sewer pump station performance and wet weather performance as well. So I'll just go ahead and share screens. Yeah, and so today's presentation is titled Quick Water Balances with SensorClean. Can everybody see my screen before I?
Yep, got it.
Yep. All good.
All good.
Great. Yeah, so title of the talk today is Quick Water Balances with SensorClean. It's mostly software demonstration. But before we get into the software, just want to start on a bit of terminology, just so we're all on the same page. So yeah, if we're interested in looking at this green DMA, this district metered area or subsystem, it usually has an inflow flow meter capturing the time series data, and then you might have a reservoir water level or a tank water level. And you might have an outflow as well. So looking at the water balance equation up the top, on the left-hand side, we've got our consumption, and then we've got our inflow volume from our SCADA flow meters, outflow volume, reservoir contribution, and then we've got the not all-important non-revenue water volume as well, which is our low-level leakage and pipe failures, etc. So today when we jump into SensorClean though, and you see consumption, I just want to make the point that it's currently just referring to that SCADA inflow data, outflow data, and reservoir contribution. Though I do note in the coming months, we're going to be moving towards allowing the user to upload the property consumption data, which is mostly at 3-month time steps, so we can more accurately estimate the non-revenue water component. So today we'll just be looking at the minimum night flows for our low-level leakage and water loss from pipe failure events. So I'll just now jump over into SensorClean. Can everybody still see my screen? Sometimes with Teams, can you see SensorClean now or?
We're
No,
still seeing your slide with the graphic, the green and blue graphic, Gareth.
Okay, cool. I'll just quickly stop sharing and then I'll just jump over into SensorClean. Great. Can everyone see SensorClean now?
Yep, all good.
Awesome. Cool. So yeah, just on the left-hand side here, just to give you a bit of an overview, this is what we're calling the menu panel. So in the new data section, you can drag and drop CSVs for potable water flow and reservoir water level data, or we can connect in through the backend API for the bulk data transfers in and out of SensorClean. The Your Data section, that's kind of the gateway to all of the dynamic visualization for single sensors and systems, DMAs, and we'll certainly be looking at that today. The Use Cases section, we can run automated reports for peak flows, non-revenue water consumption and data quality. The Download Data section, at any time, if you want to just do your own analysis, you can download your data at a range of different time steps there as well. And we've got a community page there as well. So we're currently just in Your Data systems. Today we're going to take a look at DMA 22, and here we're just listing which time series data sets are associated with inflow, reservoir, or outflow. So I'm just going to go ahead and click on the big V for visualize and take a look at DMA 22. Great. So the first big plot that you'll see here is what we're calling the label summary panel. Now, the very top plot that you can see is our DMA's daily consumption. The second plot that you can see is just the inflow volumes contribution to our DMA at daily time steps. And the third plot that you can see is just the reservoir's contribution, so it's the daily delta volume. And so by applying a water balance equation on these second two plots, we get our top plot, which is our resultant daily consumption. So just staying on this daily consumption plot at the top, you'll notice that there's a lot of blue data there. And so that's corresponding in the legend to what we'd call consumption include. So you can kind of think of this as all of your good data that you want to use in consumption analysis. And the red data that you can see in the plot, in the top plot, is what we're calling consumption exclude. So you can think of this as the bad data or the events that we just don't want to use in consumption analysis. For example, pipe failure events. So what's going to happen, we're just going to step through and label a couple of events of interest. And this panel is going to update with different colors as we do that. But before I do that, I just want to touch on why we label events of interest. Now, the first reason is for machine learning purposes. And that's not only for SensorClean, that's with the greater ecosystem. So the design philosophy with SensorClean is that data cleaning and labeling for machine learning is only performed once, and it's available to all engineers and all other projects, including machine learning projects. So we really wanted to kind of reduce any level of duplication that's going on by kind of moving to a cloud system or platform. So first reason why we label data is for machine learning. The second reason why we label data is for use case filtering. So using the example of pipe failure events, we do want to include those in non-revenue water. We are interested in those, but for a peak flow use case, we don't want to include pipe failure events. So two reasons, machine learning and use case filtering, is why we label events of interest. So I'll just move on down now to what we're calling the investigate panel. So now looking at our DMA's daily consumption. The color that you can see is the daily maximum temperature. So we've just brought that in. Obviously, there's a strong correlation with consumption. And you'll just notice that as I click on any of these events, the diurnal profiles are appearing. So making it really easy to explore our data. Now, the other thing that we can do is look through the lens of hourly consumption box plots. So this is really useful to pick up on anomalies at the hourly aggregation. So again, just by clicking on these events, we can take a look around. And then finally, for the really fine events that we don't pick up on at the daily aggregation or the hourly aggregation, we can go to 1 minute consumption. So here we're looking at our daily minimum and maximum 1 minute consumption. And so again, we can click on these events and the hourly profile panel is updating below. So what we'll do now is we might just take a look at this event down here for the 24th of November. We've got a reading of almost minus 60 kiloliters, so it's clearly something funny going on. So I've just clicked on that event there, and which 24th corresponds to this day. So something funny going on there. Also looks like there's something funny going on the day before. So certainly want to take a closer look at that. Just a little bit of detail on this hourly profile panel. On the hover over, we're just seeing the days of the week, and public holidays will show up there as well. And that's just out, so that's just hourly consumption in kiloliters. The dash blue line that you can see is the monthly mean separated for weekdays and weekends with public holidays removed. So it's just giving us a bit of a reference point to help us pick up on unusual events. Great. So what we'll do, and then just on the hover over, daily maximum temperature is there as well. So we'll just click on the solid blue line for the 23rd of November. And so we're now just looking at the processed raw data for just our DMA's inflow and the reservoir as well. So inflow at the top and then reservoir water level is the second event there. And so what we'll do, I'll just go ahead and expand the calendars there because we saw that those events were occurring on 2 days. So firstly, what we've got here is we've got multiple lines of evidence that a true event has occurred. So there's been a dropout from both sensors that you can see there. So because we've got that multiple lines of evidence, we've got a bit of confidence in this event occurring. So I've just clicked on either side of that data signature, and I'll just click on data issues and then assign sensor offline and then assign the label. And so now on the hover over, we're just seeing the acronym for sensor offline there. And while we're at it, because we've got another event over here, let's just go ahead and click on either side of that data signature and just assign the sensor offline label. Now you'll notice there's a bunch of labels down here, which I won't go into detail today, but yeah, if you don't have access to maintenance database and you're not sure about what label to use, At any time, if that's the case, you just go with unknown and reconcile, and SensorClean will organise those signatures, those data signatures for you. So again, just on the hover over, we're seeing the acronym for sensor offline. We've clicked on those data signatures, and so moving back up now, you'll notice in this hourly profile panel that SensorClean's actually filtered those events out because we don't want to include those in our consumption analysis. So you're seeing this gap here and gap there. And similarly with our 1 minute consumption plot, you'll notice that this has kind of corrected itself because we previously had the minus 60 kilolitres, which has been filtered out. So SensorClean's organising that data for us. So what we'll do is we'll just click on the hourly consumption box plots now, and we'll just go through this process one more time. Let's take a look at this, these funny anomalies here, 18th of Feb 2015. And so sure enough, it looks like we've got a significant off-peak flow event on the Feb 18. So I'll just click on the solid blue line there, take a look at our processed raw data. So our inflow meter to our DMAs showing a significant increase in flow, reservoir water levels, giving us a second line of evidence that a pipe failure has occurred. So let's just go ahead and click on either side of the data signature, and we'll just assign the label pipe failure downstream for that one. Again, if you weren't sure, if maybe you didn't have access to your maintenance database, you just go with unknown reconcile, and SensorClean will organise those data signatures. Great, so on the hover over, we've got pipe failure downstream, and so just moving back up, again, you'll notice SensorClean has filtered that event out because we don't want to include pipe failures in our consumption analysis, but they have been organised for non-revenue water. And similarly, you'll notice with the box plots that those events have been filtered out as well. So this is just showing the consumption include. But at the daily level, at any time, you could just click on all data and go back in there, or you just wanted to look at the labeled events, you've got your consumption exclude option there as well. Great, so just moving back up, we'll just check in on our label summary panel. So this 18th of Feb, that was the pipe failure event that we labelled there for our inflow sensor. It's now showing as consumption exclude. We don't want to include that. And there's our two sensor offline events that are corresponding there, sensor offline, consumption exclude. Great, so now that our data's looking pretty good, what we'll do is we'll just move over into use cases, and we'll just run some automated reports. So we'll just come in here, DMA 22, and just run all reports so that this will be consumption, peak flows, and non-revenue water. Now there'll just be a couple of minutes of processing there. So while that's going on, I'd just like to dig a little deeper into some data quality kind of visualization and things. So I'll now just go into your data sensors. So we're now just looking at the single sensors, single time series data sets. And so the way that the kind of the workflow, SensorClean workflow works is you upload data, or it comes in through the backend API. There's a level of automated cleaning, picking up on all of the duplicates and missing values and out of sequence time steps. And there's a data quality that's presented as part of that. You can also group as many sensors as you would like for data quality comparisons. An automated report will be generated for that. And then so once that level of automated cleaning has gone on, you can come in and explore your data with the dynamic visualization. So yeah, just want to touch on, so this now is the single sensor page. So yeah, just looking at a single sensor, and I just wanted to show you that the investigate panel down here just offers the opportunity to look at sensor observations as well. So just clicking on sensor observations, I'll just start with all data. So now what we have for a single flow sensor on the y-axis, we've just got daily number of sensor observations with the daily max temperature in there as well. There's generally more sensor observations on the hot days when there's a lot of demand in the system. But yeah, by presenting the data in this way with the daily sensor observations, it makes it really easy to identify times when the sensors dropped out. So I've just zoomed in on on some days of 0 observations, and sure enough, we've got this sensor dropout here. So just introducing you to a couple of more bits of variables in this plot. So on the Y2 axis, the red data is our hourly sensor observations, and that's dropped down to 0 in this case. The dashed red line is our monthly median separated for weekdays and weekends. And then the blue data, just for our single sensor, is the hourly volume there as well. So yeah, so point being, with having the hourly sensor observations, you can identify times when the sensor may have dropped out really easily. And there's also the daily minimum maximum flow, a bit of latency on that with the internet connection. I'll let that one come up. Sorry guys, internet. There we go. So yeah, now just looking at the daily minimum and maximum flows. So this can help you pick up on the really short, sharp spikes that you get in your data sets as well. There as well. Cool. So yeah, just wanted to touch on that with the sensor observations. Let's just go and check in now on our automated reports. So if I go back to use cases and then systems and DMA 22. Yeah, let's just start with peak flows. We'll take a look at the automated report there. So just coming on down, I'll just start with our 10 highest consumption days for DMA 22. So yeah, what we've got here, this is top left is our #1 ranked event. And the blue data that you can see there is the peak hour for that peak day. And the volumes are reported in the top along with the daily temperature. Now the peak data that you can see here on this second plot here is infill data. Now this is currently the only place where SensorClean will fill gaps, but definitely open to conversations about doing that in more places. So what we've got here with this pink data is a label's been applied on that day, and so SensorClean has infilled it with the 1 minute monthly mean separated for weekdays and weekends with public holidays removed. Yeah, because so the reason why we infill for this peak flow use case is because it's critically important for infrastructure planning purposes, for probability distributions, that we don't accidentally lose true peak events. We need to put those into our extreme events, probability distributions. So that's why this is the only place where SensorClean will infill with the 1 minute monthly mean. So peak day events there, all plotted. And down here, we just present all of the sensor observations, really important around, to assess the data quality when making the high stakes decisions around these extreme events. So that's why we'll just present all of those sensor observations there too for the days and the hours. And so just coming on down now, so just looking now at our 10 highest consumption hours. So little bit of a misconception in the water industry. Maybe it's more just in the modeling space that we've kind of picked up on, and that is that the peak hour always occurs on the peak day. And I guess, yeah, from data mining from a few utilities and looking at a lot of data, probably say, yeah, that happens a lot, but not always. And that's why SensorClean will also rank the 10 highest consumption hours. And so interestingly, this blue data here for the highest ranked hour, it did not occur on the highest ranked day. So implications of, like, I guess if you were assuming that the peak hour always occurs on the peak day, you might actually be putting your system at risk of non-compliance with the peaking factors, which are presented below. So peak hour events are ranked there as well. And again, we just present all of the sensor observations. So if you're looking at a peak hour event and it's only got 3 or 4 observations, maybe you more want to have like 60 observations or 1 a minute for those events. But yeah, present all the data quality information there as well. So just the peak weeks, 5 highest 7-day cumulative volumes. Again, the pink data is just the 1 minute monthly mean separated for weekdays and weekends. So just some infilling and just the volume in the titles there. Yeah, and then we present the system peaking factors down there for your days and hours and weeks, etc. And the average day profiles down here. And in the appendix with all of these reports, we capture who's done the work. So really important to capture all things QA. And that's why we've got the the labeler down here as well. And you can download any of these reports as PDFs for your own reporting and analysis. Great. So we'll just jump back in now. Let's take a look at the non-revenue water report. So for DMA 22, just click on non-revenue water. And so firstly, yeah, just looking at the minimum night flows here, or just calling it the base flow. So the blue profiles that you can see there, that's the 1 minute monthly profiles. We're just looking at weekdays because weekends kind of have a bit more off-peak flow. And the dotted red line you can see there is the base flow, or the minimum night flow, if you like. And just in the title there, just presenting 8.6 litres a second for the minimum month. Looks like it's probably May there. So this is only for one financial year. If you've got more, they're going to show up below here, and it's quite useful for comparisons for that minimum night flow as well. So just moving on down to some of the events that we labelled. And in the title of these plots, we've just got the water loss from those events. The grey dotted line that you can see, 1 minute monthly mean, separated for weekdays and weekends. So the water loss is essentially the difference between this blue line and the monthly mean there, 1 minute monthly mean. So down the bottom, we just summarise all of the the minimum night flows for the year, if you like. And the water loss from those labelled events down here. Again, if you had more financial years, they'd show up for comparison. And yeah, the label history is capturing who's done the work for QA purposes. Again, you can download that report. Awesome. So I'll just quickly touch on, just show you the consumption report. So today we're just looking at a single financial year. And so just moving on down, so this is the daily consumption with temperature. If we had more than 2 years, then trend lines would appear for cubic polynomial and linear trend lines as well, which is capturing population growth and to a lesser extent climate change. Here we're just looking at our monthly mean profiles for weekdays and weekends. Again, more financial years, you can kind of see that growth in the catchments just appearing there. There'd be more plots here and more comparisons for more data as well. Again, label history, and you can download that report as well. All right, great. So yeah, what we might do now, actually, I just wanted to show you. I've just come in to download data for sensors, and I'm just going to go ahead and just download the daily time step data. And the reason why I wanted to do this is there's some visualization that comes with when you download your clean data, and it just kind of makes it useful to find the labeled events and deal with them for your use case as well. Just extract that. All right. So what we've got. Yeah, so you'll be familiar with this plot. So we've just downloaded some clean data at daily time steps, and I just wanted to show you that you get this PDF report with that clean data, and it's just summarising the events that have been labelled. So this top one, we've got labelled events 1 and 2, which is corresponding to those sensor offline events. And then when you, can you guys not see my screen? Sorry.
Yeah, I can't see. No.
All right, I'll just show you at a different place. Can you see now back in SensorClean?
Yep.
Awesome.
Yeah, we can.
Awesome. So this is the report anyway that comes with the downloaded data. So you'll be familiar with this plot. But yeah, you also kind of get the summary of the events that have been labelled. So in the title, got labelled events 1 and 2, which is corresponding to these two brown ones. And then when you download your clean data at any time steps, there's just a column called labeled events. And so you can filter, you can use these visuals and filter out those events depending on what your use case is. So just trying to kind of fit in with that workflow, but definitely understand that people are using lots of other tools to analyze time series data. Great, so I'll just show you some other features. So yeah, as mentioned before, you can group as many data sets as you would like. In SensorClean, a system is hydraulically defined. It's like a DMA. You have to specify the inflow, outflow, and reservoir. Where a group in SensorClean is just more than one data set. It's defined as just having more than one data set, and it provides comparison for both data quality, but it also presents these timelines. So this is a really useful place to start. Like if you've got a lot of data and you do want to move towards DMA analysis, firstly, just by grouping your data and getting these timelines and understanding where data sets are starting and finishing, it can be really useful. And it really just kind of leads into defining systems in SensorClean. So you do that with new data and system. And it's just here where you're just specifying whether a data set is inflow or outflow or a reservoir. Yeah, and just clicking on events and there's a couple of minutes of processing once you've defined your DMA or your system. Yeah, I'll just show you touch on one other feature, I guess. Yeah, so you guys are absolutely more than welcome to trial SensorClean. We've got a limit of 10 data sets per utility with just a single financial year. And to do that, it's really easy just to come in and just drag and drop CSVs. So initially, SensorClean asks you for the pipe characteristics of where the sensor is located. If you don't have that information, that's okay. You can just kind of put some existing dummy information in there. But what is important is the units of the data sets, like the flow units, for example. And it also just wants to know whether the timestamps are in UTC or wall clock time. But again, just selecting some units. So it'll then map temperature data and rainfall data for your visualization there as well. So it just wants to know which weather data to use. And then once you're at this point, you're just doing a simple drag and drop of a CSV. So you'll notice the skater tags have showed up there. SensorClean has picked up on the fact that there's headers, and we're then just brought through to this page. Now, all SensorClean is analysing is the timestamp and the value column, whether that's a flow value or a reservoir water level value. So coincidentally, this data set did have the titles of time and value, and so SensorClean has by default grabbed those. But if your data set doesn't have the column names time and value, that's totally fine. You can just really easily pull in the correct timestamp column and the flow value column, and away you go. So yeah, we've had a bit of feedback at this level. We're kind of really open to maybe having a third column and bringing in existing skater annotations, whether that's a pipe failure, or maybe there's some other like a work order information or something, which could be shown up as a different color or on a hover over or yeah, something like that. So again, yeah, so all we want to do is just drag in the time and the value, click next, and there's a couple of minutes of processing there. Right, so yeah, hopefully that kind of gives you a bit of an overview for the software. Another good feature is because it's in the browser, you can have multiple tabs open in SensorClean, and so you can really be looking at a lot of data from many systems by having multiple tabs open. But yeah, obviously it does use a bit more internet bandwidth in doing that, but it's very powerful to have that open. All right, so I might just conclude things now. I'll just I've just got to, I'll stop presenting and then I'll jump back over into the other tray. Just so, can everyone see my screen? Just back on the PowerPoint presentation now, is that?
That's good.
Yep, awesome. Yeah, so just want to summarize what we've kind of looked at today. Yeah, so we've just done a system water balance for a DMA, just with an inflow sensor and a reservoir. And we just did it for 1 financial year. We estimated non-revenue water, peak hours, days and weeks, and peaking factors, consumption, and did touch on some data quality stuff as well. So prior to this presentation today, I'd spent about 10 minutes labeling those other events that we had there. But the total time to conduct all of this work was 25 to 30 minutes. So significant saving in time. We're estimating that in using SensorClean, it's about 10 times faster than spreadsheets for your water balance work as well. So in conclusion, yeah, thank you very much for listening, and yeah, thanks for having me along today. Really appreciate the opportunity to present, and yeah, probably a good time to open it up to questions. So thank you.
Great. Thank you very much, Gareth. Really interesting. Every time I see SensorClean, I think, wow, I can't imagine just trying to do that on a spreadsheet. You know, I don't know where I'd start. But you know, in today's world, the visualization of information is just, you know, such a given, isn't it? That
yeah,
you know, we expect to be able to interpret it visually in so many different ways, graphically, you know, and not just statistically. And so it's yeah, I love the if you like, almost the human-centered aspect of this tool.
Yeah.
We do have about 6 or 7 questions on our Menti board, which is great.
Yep.
So I think we've got time to get through many of these, haven't we, Jason?
We certainly do.
So I'll start with the top one, which is what is the added benefit of using SensorClean when compared to using SCADA? And I would add a bit of I'm presuming the question's around the fact that SCADAs have historians of time series data, right?
Yeah.
So yeah, so the added benefit as you see it, Gareth?
Yeah, I think first and foremost, SensorClean is primarily for planning engineers and asset management engineers. It's not currently operating in the real time as SCADA does. So yeah, and I totally acknowledge that SCADA's got plenty of tools. But yeah, if you're doing like the planning work, the water balance work, it's primarily spreadsheets, and it's hard work. Yeah, it's really it's really kind of catering to the planners and the asset management people as well. But yeah, definitely want to move towards the real time in the you know, coming years, or when appropriate.
Interesting. Yeah. Yeah, great. All right. Next one is has there been an effort to connect field data, such as burst reports, with the system to remove anomalous data automatically? Because manual reviewing and anomaly identification, you know, could be time consuming. So
yeah, definitely. Yeah, I guess it's all headed towards automating this process on the systems page. So basically, yeah, we just need examples of the different data signatures to train machine learning models to learn what they look like. So yeah, through the R&D process, we definitely played around with a lot of statistical rules and ran artificial neural networks, and just realized that we really need to clean and organize the data, so we don't have a garbage in, garbage out scenario with the machine learning models. Yeah, that's a big one. But yeah, definitely as time goes on, the idea is definitely to make this workflow more and more efficient. But currently about 10 times faster than spreadsheets for water balances.
Yeah, that what you showed us before around adding a column where you could bring in other system data was quite interesting, because if some of your failure data, for instance, can be put into a relevant, you know, time stream, then yeah,
absolutely.
Yeah. All right, I'll keep going, Gareth, if you're up for it.
Yeah. Thanks, guys. Thanks for the question.
All right. Similar to that in terms of automation,
Yeah.
can the system automatically identify potentially anomalous results based on statistical analysis, or is it based on user revision only?
Yeah.
So similar.
But firstly, yeah, probably just, the other thing I didn't add, this question follows on a bit from the second one. Again, yeah, through R&D, we realized there's a huge amount of diversity with these sensors from utility to utility. You get really poor data quality and good data quality, and numbers of observations as well. And so, yeah, again, definitely tried lots of different statistical rules, different standard deviations. Let's look at this and that. You can do some good rules with physical rules, such as if you've got the internal diameter of the pipe, what's a realistic maximum flow, and so anything higher than that you can go for. And I guess also with the reservoirs, with if you've got the diameter of the outlet pipe, what's your maximum probable kind of maximum rate of change. So there are some physical rules, but yeah, I think we kind of just fell back on, okay, let's just have really good visuals and organize the data signatures for machine learning. So yeah, really want to just move towards automating the identification of the data signatures, and so it'll just be kind of a reconciled bunch of data signatures for the user ultimately. But yeah, that's kind of where we want to go. So I might have been a bit vague in actually answering that question, but I hope
it sounds to me, if I could summarize, Gareth, that you've all tried a lot in this area so far, and that's still emerging. It sounds like the
plan on getting the machine learning models. We're planning on getting them ticking over in the second half of the year, and yeah, it's interesting having conversations with utilities and just understanding the different quirks and problems that they have. So yeah, interesting. Thanks, Kev.
All right, just no worries, just a couple more, Gareth, and Jason, pull us up if we're running out of time. Can similar type of analysis be done on geographical area or customer cohorts? I find this a little.
Yeah, that's a great question. Yeah, as mentioned at the start of the presentation, in the coming months, we're going to move to allowing the user to upload property consumption data, so we can more accurately get the low-level leakage. In terms of implementing GIS, it's probably not a super high priority at the moment. Rather, machine learning is. But yeah, if there's a strong interest for that, then we could do that. But yeah, ultimately with pressure data as well, it's useful to have the GIS data as well. So we'll ultimately kind of move that way. But yeah, happy to have more conversations as well.
Yep. Keep going. I noted that SensorClean can generate a report straight out of the data. Can you customize the format of the report to suit different organizations?
It's a great question. Currently, no, in answer to that question. Yeah, we're definitely trying to modularize all the reports more and more, so and move towards more customization. We recognize that the operator or a modeler doesn't necessarily need to see the same report as maybe like a high-level management report and things of that nature. So in answer to your question, currently they're all fixed, but yeah, it's we do want to move towards more customization. Sure.
Yep. Actually, I'll just add one of my own in there.
Yeah.
Are the classifications fixed? Can you add your own classifications there?
There's actually not currently a custom one that will be implemented. Yeah, that's a very quick fix. That hasn't come up yet. But yeah, we actually want to. We kind of initially started with, okay, let's just try and cover as many bases as possible with the labels. So we've gone pretty far and wide. We do want to kind of simplify things for the user. Yeah, and I think absolutely having a custom label is part of it. Yeah, but it's really kind of just getting things organized for machine learning just to make this process quicker. But again, yeah, as mentioned before, if you label events in here and there's other machine learning projects going on at your utility, then yeah, we really want to fit in with the ecosystem and for other projects to benefit as well. So.
Yep, great. Age-old question, cost?
Yeah, that's a great one. Yeah, so SensorClean is pay for use. You only pay for it if you're using it, and the cost is linked to the number of data sets. Using the example of let's say you've got 50 data sets. Up front, you're looking at a cost of around 36K, but then in the second year it is a subscription model. That cost significantly reduces to about 12K, 13K. So yeah, it's pay for use, and it provides economy of scale. So the more data that you upload, the cheaper the rate as well. So more than happy to send around just a bit of a summary on the costing stuff too. Might help. Yeah,
great. Thanks. And as you said before, you can give it a trial go.
Absolutely, yeah.
A small amount of data. Here's an interesting one. Do we have to retrofit our data into the data model for SensorClean? And how should the data, and how old should the data backdate to? So 2 years ideally. I mean, there's two questions there. First one on fitting your data model.
Yeah, that's a good question. In terms of how far back you want to go, I guess it depends on the use case. Is always what it comes back to. What will the data be used for? For example, if you're interested in forecasting, more data is always going to be better. Yeah, in terms of retrofitting, like we definitely realise that utilities have already done a huge amount of work with annotating data and cleaning, etc. Yeah, and we're not trying to kind of reinvent the wheel, and yeah, we do want to allow the user to bring in more information. So existing annotations, for example, having that third column when information's coming in, so you can kind of bring in existing labels and other important information when analysing these data sets. So
I guess part of what might be behind that question is is there a lot of work to reconfigure your data before you upload it? And
oh no, it's just timestamps and value, and then the base clean, the algorithm just deals with duplicates and missing values and corrupt items and out of sequence timestamps, and just presents an automated report for that. So it's just the timestamp and value.
Yep, so pretty straightforward. And you're working on APIs, I think, or are they available?
Yeah, we're all set up, ready to go with the backend APIs. So yeah, it'll be straightforward to connect in through the your existing APIs. So.
If you want to do it that way. Yeah. Last one, I think. Any out of the box analysis available around sensors maintenance, life and failures across different dimensions, so manufacturers or climate change affecting. So that's around the sensor performance itself.
Yep, that's a great question, and definitely want to keep improving data quality. So yeah, I just brought in just to kind of help answer that question and show you what is going on at the moment, but where we want to go to. So yeah, when you group your more than one data set, you're provided with some key data quality metrics and things for comparison down the bottom here. Yeah, and then in terms of just really getting organized with, so at the moment this is automated, and so using the example of there's metrics around the percentage of hours offline or the percentage of days offline. If you've got an example where there's a pump station that's only pumping intermittently, of course you're going to have more percentage of hours offline, or percentage of hours with zero observations than maybe a flow meter that's out in the network and there's a lot of change going on. So currently Yeah, we have a level of automation for the data quality, but we want to use the sensor data issue related labels and to organize those more and more. And so you can start to kind of get some metrics around sensor performance, but there's a lot of complexity in it because it could be power failures or PLC failures and other things going on. But yeah, definitely want to just keep getting organized around all things data quality with sensor dropouts and things. So for decision making for sensors. But yeah, so currently just what we can automate with the data quality stuff.
Great. Jonathan, did you have a final question that we missed there?
I just thought there was one in the chat from Swati.
I know we actually
Did you
copied
cover
and
it?
pasted
Yeah.
that into the Menti,
Oh,
so
cool.
that's
Thank
been
you.
that
Yep.
it's actually been addressed.
Cool.
So all good. So thank you, but thanks for picking that up. To know we had an eagle eye on the chat during the session. So look, I think, and spot on time too. So thanks so much, Gareth and Kevin, for being a wonderful host and a tremendous presentation, Gareth. There's a few people in the chat who'd like to find out some more information, so we'll pass that on to you after this session. I'd like to thank everyone for attending today. We went for quality over quantity. In fact, I think it's the highest question rate we've ever seen. It was one question per participant, I think it was today. So that goes to show you how much engagement there was with people in this topic. So thanks so much, Gareth. Really appreciate your presentation today and sharing it. No worries. Cheers. So look, just a reminder that the webinar recording will be available on the Knowledge Hub in a few days' time, and Alyssa has put in the chat the details of how to get to the Knowledge Hub, and if you're not registered, the registration details there. If you need any additional information or you have any inquiries, just pop Alyssa an email and she'll be happy to answer that for you. And look out for an email coming your way with the next webinar date and details for May. But for now, that's all from us at the IWN. Thanks so much for your attendance today and have a fantastic long weekend coming up.
Great.
Cheers.
Thanks a lot, everyone.
Thanks, everyone.
Thanks.
Have a great weekend.
Thanks,
Bye.
Cheers.
Thanks, Gareth.